In this video, we are going to look at the derivation of Bragg's equation. And to derive Bragg's equation, we are going to base our set of argument from the Bragg's law. And before we start, if you are new here, please take a second or two, then subscribe to this channel, then like or comment. Now let's start. The Bragg's equation, we shall start it by looking at the effect of the diffraction of the X-rays on the surface of the crystals. Now let's treat this as our ray 1. This is our ray 1, our X-ray 1, and we shall have our another X-ray 2, our X-ray 2. Now this ray 1, when it strikes the surface of this, now the crystal, this is the crystal, this is the thickness of the crystal, we shall call it D. Now when the X-ray 1 strikes the surface of this atom, the ray 1 shall be reflected back. After ray 1 has been reflected back, we shall have another ray 2 which will penetrate through this crystal. Then it shall be reflected by this surface of the crystal. Then after being reflected, it will penetrate through this surface, then outward. So we are going to base our set of arguments here. Now this ray 1 and ray 2. So to derive the Bragg's equation, we shall have to consider the ray 1 and ray 2. We realize that the ray 2 will travel a longer distance as compared to the ray 1. Now let's consider the extra distance traveled by the ray 2. We shall have to draw a dotted line here and a dotted line here. So this distance from here to here is the extra distance traveled by the ray 2 in relation to the ray 1. And this extra distance traveled by this reflected ray 2 compared to the distance traveled by the ray 1, we shall have it here. So this is the extra distance. So we shall call this place X and this place Y, and then this place Z. So the ray 1 traveled an extra distance of XY, then YZ, so that it can catch up with the ray 1. So this extra distance XY and YZ, when we add them up, then we shall get the wavelength of this X-ray. So XY plus YZ is equals to the wavelength of this X-ray. So the extra distances traveled by the rays gives us the wavelength of the X-ray. So we shall have here our N. This N means the order of the X-ray. So we realize that here we have an angle here, an angle theta, which is equal to the angle theta here. So this extra distance traveled by ray 1 before reflection is, we are going to call the angle due to it, we are going to call it theta, which is equal to the angle theta, which is as a result of the reflected ray 2. So we are going now to relate these extra distances so that to arrive at the wavelength of our X-ray. So to find this theta, we shall have sine theta is given by, sine theta is always given as opposite all over hypotenuse. So the opposite of this theta here is our line XY. So our opposite shall be our line XY divided by our hypotenuse here shall be this distance here, this perpendicular distance, of which we are calling it, for this case we are calling it D. So we shall have divided by D. Now when we relate it, sine theta is equal to XY over D. Now when we want to make xy to be the subject of our formula, then we shall have to multiply here by d, then this side also by d, so that we get xy is given as d sine theta. So this is our line, this is the distance of our line, the extra distance xy traveled by the ray 2. So we want to find the extra distance yz. So yz shall be given as sine theta, which is our other theta here. So sine theta is given by opposite over hypotenuse. So our opposite shall be our line yz. So our opposite is line yz divided by our hypotenuse. Hypotenuse is also this line d. So distance d is our hypotenuse. So when we want to make yz the subject of our formula, we shall have yz is equal to d sine theta. Now after arriving here, then we shall come back to this equation. Let's call it equation 1. We shall have to relate this equation 1 with whatever findings we have gotten here. So we got that xy plus yz is equals to n lambda. So our xy we've gotten as d sine theta, then plus our yz we've gotten it as d sine theta. So is equal to n lambda. So is equals to n lambda. So when we add this d sine theta plus d sine theta, then definitely we shall get 2d sine theta, then is equal to our n lambda. So after arriving here, this is now the Bragg's equation. Bragg's equation. So this 2d here is, we shall have it as a constant. Then d is the distance, or rather the thickness of the crystal. Then sine theta. Then n is the order, and then lambda is the wavelength of the X-ray. Thank you for watching.